Hey, welcome back. Today we're going to be discussing energy. They're not making any more of it. Alright, energy. The first type of energy we're going to be discussing today is work. Work is indeed an energy. The way you can identify the energies is they will typically have units that are in joules. What is work? Well, work is force applied to an object for some distance. You do work when you open a door. You apply a force because you're pulling on it, and you pull on it for some distance. When you push with your pencil, you're doing work because you're pushing down and you're making a mark for some distance. When you get up, you push. You might push off the desk. You might, for a distance, when you stand up, you push with your feet and you go some distance farther up. So all of that is examples of work. And our equation for work then, as you've heard me say several times here then, is force times distance. It's force times distance. Alright, energy is measured in joules. And what we're trying to show here is that something I said earlier. Energy is measured in joules. Well, work is measured in joules. So then work must be energy. Alright? If you're doing work, then you're using energy. We'll just leave it at that for right now. Okay, the next type of energy I'm going to talk about is energy in motion, called kinetic energy. Example, a boulder rolling down a hill. It's a boulder, and it's moving. So that right there is a perfect example of kinetic energy. Kinetic energy is 1/2 mv squared. M standing for mass, v standing for velocity. So what we do is we have to identify the mass, which is the boulder, and the velocity, we'd have to give it some speed. Maybe it was rolling at 15 meters per second. So if I were to relate kinetic energy to an example, I'd have to relate the mass to something and the velocity to something. So a car has kinetic energy because the car is the mass, and if it's moving, it has velocity. Examples here. I'm going to write my equation here. Kinetic energy equals 1/2 mv squared. In the first case, it's 1/2. 1,000 kilograms is the mass. Because it's in kilograms, I know that that's the mass. And the velocity is 4 meters per second, so it's going to be 4 squared. When we do that, we get an answer of 8,000 joules. Okay, let's look at the second example. My mass, well, that's 500 kilograms, and my velocity is here, 22 meters per second. So it becomes 1/2 of 500 times 22 squared. Our answer then becomes 121,000 joules of kinetic energy. Okay, the last energy I want to talk about today is potential energy. All right, potential energy is stored energy. A rock sitting at top of a ladder or sitting top of the hill is potential energy. Specifically talking, it's gravitational potential energy. Because gravity's pulling on it. There's all types of stored energy. We can have chemical stored energy like gasoline or food. We can have elastic potential energy, stored energy, such as a rubber band, if you pull a rubber band, or a bow and arrow, or a crossbow, or a spring. Those are all examples. But the type we're going to talk in class about specifically is gravitational, and it's going to be this equation right here. So as we look at our examples, potential energy equals mgh. In my first example, the mass is 25 kilograms. G is easy, I know that to be 10, and the height is 3 meters. Well, when I figure that out, that turns out to be 750 joules. 750 joules. Let's take a look at the second one. Equation. 10 kilograms is my mass. 9 meters is my height. So it's going to be 10, gravity is 10, the height is 9, so the potential energy here is 900 joules. Alright, in these last 4 examples here, I want you to go ahead and calculate these. You're going to be using our potential energy equation and our kinetic energy equation. Again, calculate these energies, and first of all, you're going to have to identify whether it's a potential energy or a kinetic energy. Kinetic energy is if it's moving. Potential energy would be if it has stored, or a lot of times I like to look at it and say, does it have some type of height? If it does, then it's potential energy. Well, hey, you guys work these out, and I'll catch you on the flip side.